Hey guys, RPro here, and in this one we're going to be talking about fundamental data types. Now, before I forget about it, we need to talk about something from the last video, and it's why I was assigning those integers and doubles to 0. Now, I'm going to declare me an integer here. I'm just going to call it num, and I'm going to output num, and we're going to see the result. So we'll go ahead and build this, and you'll see the warning here, and it says it's uninitialized. So let's go ahead and execute this and find out why it's complaining about that. And as you can see, we see a number here seemingly pulled out of nowhere. And where that number is coming from is when we declare this integer, it collects a value that's already in memory in that location. And essentially that is called trash value, and because we can't predict. If you go to create a program and then you close it, whatever, do some things, and then come back later on and try to do this again, you might get the same thing, but you might not. So it's essentially not really predictable as to what trash value you're going to contain. It's going to be contained in this integer, and that is bad. So we don't really want to deal with trash values. We want to deal with something a little more predictable, something we've defined. So how you do that? You simply just assign it something. In this case, I'll assign it 0. So that's pretty typical thing to do whenever dealing with integers and doubles and whatnot. And that will simply get rid of the trash values that's in that integer when you declare it. So we'll build and run this again. And as you can probably predict, now we have 0. And we know where 0 is coming from because we assigned it 0. So that is why we need to do that with the integers and doubles whenever we first declare them, because we don't want to deal with trash value. Now notice it said such and such is uninitialized in this function. Well, this is referred to as initialization. Whenever you declare an integer or a double or any numeric data type for that matter, and sometimes even a character, which we'll get to here in a second, then you need to assign it something to get rid of any kind of trash value that it collects from memory that was already there. So that's how you do that. This is referred to as initialization. So now that we've got that out of the way, let us go ahead and continue with the tutorial about fundamental data types. So we will get back to integers later. Right now we're going to deal with the data types that we haven't talked about yet. And that is the character. So here's how you declare a character. And a character is heavily linked to the Ascii chart. Now, what is the Ascii chart? So I've got it pulled up here from cppreference.com. I'll have this linked in the description below. And we have 128 different things in this Ascii chart. Now, this ranges from the null character to the delete character. And we've got all kinds of simple goodness inside here. And we can assign these to a character by their represented decimal type, or the decimal number that's represented by them. So let us go ahead and assign the capital letter G using the Ascii chart. So what I can do, I can say character alpha is assigned 71, and then I'm going to output that. So I'm going to output the variable alpha, and I'm going to go ahead and build this and run. And as you can see, I get the letter G, and just because I've done that goofy little thing right there, I'll just go ahead and rerun it. And as you can see, there we go. See, that's the letter G. Now we can get that 71 instead of the ASCII representation by simply doing something called typecasting. So we'll get the casting later, but I just wanted to show you that real quick because it can be pretty useful. So we can make and then run it, and as you can see, there we are, 71. So I'm typecasting in the output to make it show 71 instead of the ASCII representation of 71. So there you go. There's two ways you can deal with a character whenever you're assigning it like an integer or a double. Do not store decimal point values in a character. Do not. They're not equipped for it, and you will not get the expected results. So like 71.1, we try to cast this to a double, for example, and let's just go ahead and see what happens. It might work, it might not. I've never done it before. We didn't get no errors. And we got 71. So that is what I was talking about. So when it didn't throw an error message, I thought, well, hey, this might work. But characters are not equipped to deal with floating point numbers. So keep that in mind, guys. If you try to deal with this as well, let's just see what happens with this too. I'm in an experimental mood. And as you can see, it chopped off the decimal. We got the letter G because the letter G is represented by 71 on the Ascii chart. So, you know, it's pretty cool. You can play with the Ascii chart with the character and all that good stuff. Now, we don't have to deal with the Ascii chart. We can assign it sort of like you can a double or a integer, things of that nature. And with the character, all you have to do is assign it with the single quotes. Now, here's what this looks like. So I'm going to assign lowercase a this time. So I'm going to say alpha 2 in this case. And then you use the single quote here, and you type in the letter A, and that's it. So if I go ahead and see out alpha 2, then it should output the lowercase a. So I'll go ahead and build and run this. And as you can see, there's a letter A. Now you can also store symbols and numbers within a character as well. Excuse me. That was bigger than I thought. I'm sorry, ladies and gentlemen. But first we'll try to store a symbol in the character, and we'll just call this symbol, I guess. And we can do this in two ways. Once again, we can, I believe it's the number 9 in the Ascii chart. Let me double check that. Horizontal tab. Yep, that's the number 9. And then we can, in the next one, we'll declare a character and we'll call it number. And we'll simply put single quotes here with the number 5. That's how you store 5 as a character, besides having to typecast it, which I'll do again here in a second. You can do it that way. So we simply see out symbol, number, and then we'll end L. And then the next one, I'll do the same thing in this next one. It's gonna essentially do the same thing, except we're dealing with it a little different. So I'll declare another character. I'll call it tab. And then we can use the C++ way to call a character a special character. So in this case, like you would the new line character, you can push /T. That is a tab character in C++, as well as in C, by the way. And we'll say num for this one. And we'll simply assign it 5. Now, if you're not character, of course, what is the number 5 in the Ascii chart? That is the, whatever the heck that is. So, we want to avoid that, because I don't know what it's going to output. Probably won't output anything. So, we can simply say cout tab typecast to int num and L. So, let's go ahead and see what happens here. Voila. So, there's two ways that you can use a symbol with a character and basically output a number that's held from that character. So that's it, guys. That's pretty much how to declare a character and how you can use it. So now we can deal with the Boolean. There's pretty much the second type we'll be talking about, and they're really simple, guys. They can either be true or false. And the output of these is even simpler. Alright, now we'll go ahead and we'll clear this out. And I'm going to build and run it. Alright, now true is represented by 1, false is represented by 0. And that comes from how functions used to work in the C language. If everything was good, pretty well, in the C functions, it would not represent 0, it would represent 1. Otherwise, you know, if something would happen, it would represent 0. So, there you are. That's kind of the basics of how a Boolean works and why it works that way. Now, of course, if I got that backwards about the 0 and the 1, correct me in the comments below, guys. Always correct me if I'm wrong in the comments. So now we can go back to the integer and the double. Now, first we'll talk about the integer. And this is referred to as an integral type. And it does not store a decimal number, it stores non-decimal numbers. Now, there's different types of integers. We have the short, the int, the long, and the long. Now, these are all, well, not all different, but this is the shortest type of integer, and these two are essentially the same. They really are. I can show you here in a second on how. And we have the long, and this one's completely different. Now, once again, the short contains the shortest integer. It contains the smallest number, and it's the smallest in memory. It's only 2 bytes in memory. Whereas a character, what we dealt with earlier, is 1 byte in memory. This is 2 bytes. And the integer and the long are both 4 bytes, and the minimum and maximum values they hold are identically the same. So to me, somebody can tell me in the comments on how they're different, but to me they're the same. And I'll show you what I mean here in a second. Now, the long is completely different. It's 8 bytes in memory, and it has the biggest minimum and the biggest maximum. Now, there is a specific term for minimum and maximum values with the data types, or any data type for that matter, and it's called the floor and the ceiling. Now, I can show you what I mean by things being identical. So we can include the limits library here, and once again, you can find these libraries on c++.com by clicking the reference hyperlink on the left there, and you'll be able to see all the libraries you'll be able to use in C++. Now, in order to use this numeric limits library, you can be able to use the methods of this numeric limits object to see the minimum and maximum values of these data types. So, and if that confuses you, just trust me and type in what I type here to see the difference of any data type. So we'll see out the size of an integer is, when in this case we're going to use the size of function, and it's built in C++. You don't have to call a library to use size of. So in this case I'll just say int, and then I'm just going to put bytes here, and then I'll use that new line character instead of an indel object. Now, I'm also over here going to use this numerical limits to be able to see the minimum and maximum of a regular integer. So, in order to do that, we'll use cout again, and we'll put numeric limits, and this is referred to as a template, and we'll cross that bridge when we get there, guys. But within the template brackets, we need to put the type that we're wanting to know the limit of, and that's an int. And then we use what's called a scope resolution operator. Once again, we'll deal with that later on. And we will call the min function, or it's actually called a method if it's attached to an object, but I'll call it a function for now. We'll use the min function. It's attached to the numeric limits, and then in the line. And then the next one, do the same thing. And this time we'll call the max function. That way, we can see the minimum and the maximum of an integer. And then I'm going to copy all this. I'm going to put an extra indel in here to give me some space. And then I'm going to paste this. Now, I'm going to change all these to a long. There we are. And now I can show you what I was talking about by the integer and the long being essentially the same thing. So we'll go ahead and make this, and then we'll run it. And as you can see, the size of an integer in memory is 4 bytes. And the size of a long is also 4 bytes. And the minimum, the floor, and the ceiling of an integer, as well as a long, it's the same. They're all the same. So that's what I mean by, I don't think it really matters which one you want to use. You can use an int or you can use a long, as far as I'm concerned. So, but like I said, if there's any difference between them that I'm not seeing, let me know in the comments below. But as far as I'm concerned, they're the same. So it doesn't matter which one you want to use. Now, we also have variants of these guys. So I'm going to go ahead and retype these. So you can keep all that in mind with the numerical input. If you follow it along, you can save it if you want to, but I'm getting rid of it so it doesn't clutter the tutorial. I'm going to go ahead and retype these, and there's also variants to all these. And what I mean by variants is there's also the unsigned variants. And I'm just going to type one, but there's also an unsigned int, unsigned long, and unsigned long. Now, what is the deal? What's the deal with the unsigned keyword, and what does it mean? Now, whenever you declare an integer type by itself, or an integral type by itself, you essentially are declaring it signed. Now, what that means is a signed integral type means it can be positive or it can be negative, whereas an unsigned integral type can be positive, but it cannot be negative. So that's a pretty quick explanation. As well as it's not being negative, it has a higher ceiling. So that's what you're seeing right here. You're seeing the floor and the ceiling. This for an unsigned type becomes 0, and this becomes even bigger number. Essentially, if you were to do this to an unsigned integer, if you take this number, ignoring its negative, and you add it to this number, that will equal the size, the ceiling, excuse me, of an unsigned integer. Plain and simple. So, guys, that's going to cover integral types. Now we can move on to the last type, and that's the floating point types. Now, there's only 3, because keep in mind there is no such thing as an unsigned floating point type. There's never been a such thing in C or C++. So, 3 simple types in the floating point types. Go ahead and get me a drink so I can quit coughing in the video. Now, we have the double, we have the long double, and we have the float. Now, we've covered double before. It's 8 bytes in memory. It's twice the size of an integer, and it has no problems storing a integral type whatsoever. Now, excuse me, a long double, this sucker is 12 bytes in memory. So you can imagine this has the ability to store the longest number in C++, and as well as its floating point variants and all that. So this is our most precise type. And now we have the float. Now the float, I believe, is a little older than the double. It's only 4 bytes in memory. I could be wrong with the age. Correct me in the comments once again. But this is, I do know for a fact, this is a less precise type than the double, and it's only 4 bytes in memory. So what's the deal? Why float over double or vice versa? Well, that depends on what you're programming for, guys. There's some cases where you may want to use a float because it's only 4 bytes versus the double, which is 8 bytes. And there's other variants that make it where the float would be beneficial over the double. But I can tell you for an absolute fact that throughout my C++ series, we will be programming on an operating system most likely. If you're following me on a cell phone or something like that, I can't make any promises as to how accurate this is, but if you're dealing with a desktop or a laptop environment where it's Windows, Linux, or a Macintosh, Mac, I can assure you that it's not going to matter whether you use a float or a double, but I would recommend using a double, but simply because it's a little more precise than the float. I forgot how many decimals, you may have to look this up. I forgot how many decimals a float can keep up with, but I'm pretty sure the double can keep up with something like 15 decimal places. But I could be wrong on that one. So once again, correct me in the comments. And that's it. Guys, that covers pretty much the fundamental data types. If I left anything out, this is, you can basically use this to hang on, there we are. You can basically use this to correct me in the comments in case I'm wrong about anything. But if you go to tutorials in C++.com and click this C++ language tutorial, and you go to variables and types, this will basically show every single one of them, the things that I did not talk about, such as the unsigned character, which is essentially the same explanation as what we dealt with integers and unsigned integers. It has a basically an unsigned character cannot be negative, and they have a negative number. I believe the ceiling of an unsigned character is 255, and we had these other data types that I did not talk about. So you can look those up at your own leisure, as well as other types that we'll get to much later on. So guys, I just wanted to show you this right here. I can leave this in the description below in case you want to read over this and say, haha, I found something he was wrong about, and then you can throw it in the comments, and I can tell you congratulations and all that good stuff. So guys, that's pretty much it. If you liked the video and you thought it was useful, give it a thumbs up. Feel free to subscribe. If I made any mistakes, leave it in the comments below. And guys, I'd like to thank you for watching, and happy coding.